Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day. Actually, we will solve two problem today, and I mean the problem which was yesterday was the first version of this problem, and this is the second version of this problem. So only the difference is the constraint. So we will see both the problem in today's videos, and we will see what should be our intuition for both, because you can see that the first problem is the easy level problem and second one is the medium problem. So I will let you know that how we will we will change our approach for if the problem is easy, and how we will try to optimize it further if it is a medium or hard problem based on the constraints that are given in the problem. So all right, so let's start with the easy problem. We will start with the what the actual problem is and how these two problems are different in the constraint, and so we will focus on only the problem and then we will optimize it. Okay, so let's begin with the first problem. So the problem is maximum value of an ordered triplet. So as we always do, we will first see how we can predict the problem using the title. So from the title we can see that maximum value of an ordered triplet means that you have to find something maximum value, and ordered means that might be given in the ascending or descending order, I mean increasing or non-increasing order, or might be some other order given, and we will have a triplet. You will have to find from the title. It suggests that you have to find maximum value of the triplet. So there will be the triplet and you have to find out the maximum value. So we have not read the statement, and from the here you can see that num's length would be 10 to the power 3. Sorry, let me reset it. So it will be 10 to the power 2. So you can see that it is a very low constant. It even you can, if you will be able to solve the problem in order of n cube, that might be also good for this problem, because it is the easy problem. For the easy problem, during the contest, if you find a easy problem and you see the constant are very low, so you do not have to worry that how I can optimize the solution. You have to write the brute force solution that can be adjusted in the given constraint, and you will have to submit it. But if you're not in the contest and you are actually trying to improve your skill and you are trying to learn the algorithm how we can optimize the solution, so for this purpose you have to first think that how we can solve the problem in a brute force way, and then we will approach to the optimum solution. So this is the title suggests that you have to find the maximum value in the ordered triplet. Okay, and these are the constraints given. So now let's read the problem statement. So the problem statement is you are given a zero index array nums. So you can see that this is the array that are given here in the problem, and you have to return values over all triplet indices. You mean that I, j, k. This was the ordered means that I should be greater than j and j should be greater than k. And in case if you all such triplets have a negative value, so in this In that case you have to return 0. Okay, the value, how we can calculate the value of the triplet of indices. So if the indices you have selected from the arrays I, j, k, so it will be equal to num psi, the element that are present in the first index should be subtracted from, should be subtract, and the second value should be subtract from the first index value. So you can say that nums I minus nums j, and you have to multiply with the third value that are given in this triplet. So the problem is that you will have to find a triplet which can give you the maximum value using this formula that are given here for each triplet. So this is all about the problem. So this was the easy problem. So because you have to only choose the 3, so if we can try with n cube, I mean that because I is greater than, you cannot select a single index twice, so we will make a 3 loop and we will find all the I, j and k elements, and we will find the maximum, and if the value are negative we will return 0, or we will return the value that are given, that have been evaluated throughout the iteration. So because this is the easy, we will approach in that way, but let me show you the second version of this problem. So the second version of this problem is same, the title are same, the maximum value of an ordered triplet 2. So let me show you the constraint here. So you can see the constraint are 10 raised to the power 5, but here the constraint was something like 100 only, 10 to the power 2. So constraints are different and the values are from 1 to 10 raised to the power 6, and here the value are same, values are from 1 to 10 raised to the power 6. So this is the difference in the problem, the difference actually in the constraint. Let me show you that either the problem statement have any differences from the previous problem. So you are given a 0 index integer array nums and return the maximum value over the triplet ijk such that ijk, if all such triplets have a negative value, so return 0. And how you will calculate the values, so the formula is still same. So you can see that both of the problem are same, only the difference is constraint. So now we will first solve the easy problem and then we will move to the hard problem, I mean in the second version of the problem. So I will do that long. Further, when I will explain you the second version, I will explain you the approach how we will do. No, let me show you the how we will make our approach for the first problem, and then the same approach we will apply to optimize it. So these are the given. Okay, so from indices 0, for the 0, if I will take the 12 minus 6, if I have taken 1 and 2, and then what we can do is that, okay, into 1 it might be into 1, 12 minus 1 into 2, sorry, 12 minus 6 into 2, 12 minus 6 into 3. So from, if I've taken 12 and 6, then 1, 2 and 7 will be in the multiplication, so it is not 3, it will be 7. Okay, so again this is one iteration, and then again I will subtract 12 from 1 into 2, I mean that I am finding the difference between these two, and multiplication with 2 and multiplication with 7. So 10 minus 1 into 7. Okay, now let's take the next one from here to where 2. So this is another one, and then again 12 minus 2 into 7, and this is only the one. So from, if you will consider the first element 12 as the first element, so in the formula, I mean, formula will look like a minus b into c. So this will be, so I will consider first as the a, and from here to here I will consider the b and the c. So this is the first, and then again if I will start from 6 minus 1, similarly for index 1, 6 minus 1 into 2, 6 minus 1 into 7. This will be the 2 1. Sorry, okay. And then again 6 minus 2 into 7. This is another one. And now let's start with index 2. From index 2 we will get that 1 minus 2 into 7, and we cannot further do the same operation because we need minimum of 2 elements, and there is now 1 to 7 are at the last elements of the array, so this is only be the array. So in this case, and if you will, so this is the problem statement how we will solve in most brute force way. Okay, then we will think, okay, this is the 12 minus 6, it became just 6, it will become 12, it will become 42, it will become 22, yeah, it is 77, and then it will become 70, 10, and then it will become 35, and 28, and then it will become negative, so it will become minus 7. So you can see what the maximum is. Let me change the pen. So the maximum is here. If you choose 12 1, so if you choose 12 and 1 and then 7, so you will get the maximum, and the maximum value is 7. So this will be the answer for this problem. So let me show you one more example. I will take the last 3 elements to show you that what will happen if you will, if the arrays are given this. So in this case you will only be able to find this one, 1 minus 2 into 7, that is negative 7. So in this case you have to return maximum of 0, and what the value we get is 0, so it will become 0. So if you will get the maximum value is negative, so in this case you will have to return 0. So this is the approach for the easy problem. So let me code it now. Maximum of answer, so again No, 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 no. It will go maximum 2, will go minus 1. It will not start, it will start from I plus 1, j plus 1. So the answer will be the maximum of answer comma 1 L for the long into nums of I minus nums of j into nums of k. So this will be our brute force approach. Let's try to submit the code now. So you can see the test cases that are given here in the example have been accepted, and the first was 12 6 1 to 7. This was the array and the output is 7, and it is same as what was expected. So similarly for these two test cases that are given, and you can also see that here if 1 to 3 are given, so in this case 1 minus 2 it will become minus negative 1. So if you will multiply with 3 that will become minus 3. So in this case, because the answer is overall negative, so in we are returning here 0. So let's try to submit the code now. So you can see that our code have been accepted for the first version of the problem. Okay, let's try to move the second version now. This the time complexity for this one is order of n cube, because we are using the 3 loop here. Order of n, order of n, and order of n. If we multiply, it will become the order of n cube. So let's move to the second version. So how, because the problem are same, only the constraint are different, so how we will approach the second? So we will bring the intuition from the first example. So what we are actually doing, I will explain you my thought process, how I was trying to figure out that how I can optimize in order of n or n log n, something like that, because the constraint are given is 10 raised to the power 5. So the answer, the code will only be accepted if our time complexity is order of n or almost linear time, I mean n log n. So here what we are actually doing is that, okay, here from the 12 and again the 12 and again the 12, and we are doing the same difference. We are actually only the multiplying this. So I was thinking that, okay, here also, if we are able to, find the differences, so we will not have to find these differences, and somehow I want to reduce these 3 steps into the single step. So is there any way how we can do that? uh, so I was thinking that, okay, 1 2 and 7, so these are the 1 2 and 3 7, and for if this or the expression which we have to maximize, so to maximize, the a should be high, c should be high, and b should be low, so that the maximum will, the value will be the maximum. So I was thinking that, okay, can we able to store the indices with its value and try to sort it using in the in the decreasing order. So but there was the problem. Let me show you. mm, this is the 12. Okay, this is the 12, this is the 6, this is the 6, and 7 2 1, and then this is a 0 for the 6, it is 1 for the 7, it is 4 for this one, it is 3, and it will become 2. These are the indices on the top, and these are the array. So these are the indices. So because you indices should be in the increasing order, so if I will take 0, I can take for the 0, I can take 1 and 2. So for this one, we can only consider 0, 1, and these are not in the order. So 0, 1, and 2. So 12, 6, and 1. So these are the 12, 6, and 1. 12, 6, and 1. I guess this is the correct. Yeah, 12 minus 6, and this is the 1. So this will give you the result of 6. But sorting is not working here. How we can, why do we sort the, sorry, this was the 7. Oh my bad, this will become 4, and it should be 7. So it should be 7, should be 6, and should be 1. Sorting can, because we have sorted the array, so if we do not consider the order, so to find the maximum in the two values, the differences of two values, to find the maximum, we will always try to take the first and the last element, because they are apart from each other maximum distance, with the maximum distance. So why we do not have to consider the first and the last element, but there is the constraint that you will have to find out in order. I mean, you have to also maintain the increasing order indices to take the element from the array. So I think sorting will not work here. So now we will move to the next approach. Okay, sorting will not work because these three are we are trying to find out, and these three. So from these you can see that these are the similar, but how we will get the maximum when these are the maximum. So from these three, the maximum is 7. So why do we not consider like something? Okay, 12 minus 6. From these two, let me erase these three, all the things that are written here. So because we will have to find out the maximum, so why do we not have to think that okay, I will try to find out the maximum value, and then okay, this is the 12 minus 6, and from the remaining I will try to find out the maximum. So from the remaining I will find the maximum in order of 1. So this will be the 7, and this will be 12 minus 6. So I can I mean I can reduce this to the one step, because I will use something like because you will have to find the maximum till here, so I will use the suffix to find the maximum in the order of 1. So I can reduce this to the one step. In the similar way, we can also reduce this to the one step, 12 minus 1. So if I will consider these two elements, 12 minus 1, so I will, okay, from here to here, If I will consider these two, the 12 and this one, let me erase this 12 and this one. If I will consider these two elements, so from here to here we will try to find what is the maximum. So the maximum is 7, so 12 minus 1 and this one 7, so we can exclude this step, we cannot have to find out. So it will again convert it into the single step, and it again converted in the single step. Now our time complexity is reduced from order of n cube. From n cube we have now converted the solution into n square, because I will iterate from here to here, and I will maintain a suffix array which will give you, okay, from the next indices. If I will difference make the difference of 12 and 1, so from the next index to the till the end of the array we will try to find out which will be the maximum element. I will multiply, and that will convert it into the n square solution. Our solution will be the n square, but the constraint is, let me show you the constraint is, 10 raised to the power 5. Again it will make the n square, it will become 10 raised to the power 10, and it will not work. So now you will have to somehow, reduce this to the n, or I don't know, n log n, something like that. So how we will do that? Okay, so here now the next approach is come. Okay, we are actually, we have made for the c, we have made the order of 1 to choose the element. For the multiplication we have convert this to the order of 1. Okay, now you will have to find out that how we can optimize this to find the differences in order of 1 as well. So okay, we will try to find out the differences. So cannot we do something like this? Let me show you. We will have to somehow find the differences. Okay, and these are the element. This one is the element, and this is the first element. And the first element, to maximize this, the first element should be the maximum. So should be the maximum. As we are moving forward, if I will consider first element is 12, so for the second element we are trying to find out the minimum value, so we will not consider. Okay, what will happen if we'll try to find out something like this? Okay, now what if we will try to do something like this? Okay, similarly, because we will maintain a suffix array, suffix max array, which will store that what will the maximum till this index from the int, and from here we will again find a prefix array which will let you know that what will be the maximum value till this index we hit, because somehow you will have to find this maximum value for this one, and for this one is the minimum. So let me show you that. Okay, so this is the 12, and if we'll consider, because there will be the at least one element, so I will start from the index 1. So this is the 12 till here. I will consider that, okay, 6 is there, and the index before this one, how, what was the maximum? So maximum was 12. So what I will do is that 12 minus what was the current element is 6 into what will be the maximum value from this to this one. So the maximum value will be 7, so it will become 7. So the answer will be 6 into 7 is 42. So you can see that these three steps have been converted in the single step. Now we will move to the next index. Till here the maximum is 12, so we will find the difference. 12 minus 1 into what will be the maximum from here to here. From here to here the maximum is 7, so it will become 7 and will become 77. So I will move again this one to the next index, so I will reach it 2. So till here maximum is 12, till in this maximum is 7, so it will become 12 minus 2 into 7, it will become 70. We cannot move the index here because to find the C at least there will be the an element, so it will be here. So I will move from here to here and we will try to find out. So you can see that it is 70 and there was one more, that is 42, and there is 176. Let me tag. Okay, this one and this one and this one. So you can see we converted the solution into only the 3 step, but in the brute force 3 to 5, 6, 7, 8, 9, 10. There was total of 10 step and we converted the 10 step into only the 3 step. In the n square there was 1, 2, 3, 4, 5 and 6. So we have converted from 10 step to 6 step and then we converted into 3 step. It was the n cube, it was the n square, and then we converted into 1. So this will be the approach, but how we will optimize the solution. So let's try to code it now. So okay, we will have to find the prefix and suffix. Similarly for the suffix as well. No, this suffix. Okay, this is the prefix and this is the suffix. And now we will have to um, suffix will be maximum of I minus 1 nums of I. It will be, it will calculate the sub prefix max, and now for the suffix. It will give I plus 1. From n minus 1. So we have now created the suffix max array. I think it is fine. Now we will calculate the values for all the indexes. So we will start from 1 and we will go till n minus 1 I plus plus, and then I will remove it. Answer. It will be something into, we will have to find the differences. So I think it is okay now. Some answer. I will evaluate the value using the formula that are given. So it will be like from prefix I minus 1 to I will find the difference and will multiply with the maximum value that are will be available to the next index to till end. So let's try to run the code now. What it was happened here? I think I have to remove this one. Why is that? Sorry, it will be unequal to I minus 1. So you can see that the test cases that are given here in the example have been accepted, and let's try to submit the code now. So you can also see that our code have been accepted in the given constraint and raised to the power 5. So this was our code. So here I have found the prefix maximum array, and here I find the suffix max array, and using these two arrays I evaluate the value and return the maximum. So this was the problem statement, and this was the example one, and this was the second example that are given, and the third because the overall value will be negative, so in the case you have to return 0 in the output. So this is all about the problem. So the conclusion is that okay, whenever you will hit a easy problem where you have a very low constraint, so in that case you do not have to worry about the optimization. You will just make a brute force solution and submit the code that, but your code should be under the constraint. So if there is the problem, you will have to only make the brute force solution, but whenever you will get the more optimum higher version of the problem, so you will have to optimize accordingly. But my suggestion is, whenever there is the easy problem, you will have to always solve with the brute force solution. You do not have to worry about the optimization. So that's it. If you have any query or suggestion, you can ping me below in the comment box, and definitely whenever I will get the time, I will reply your queries that are available in the comment box. So please share, subscribe, and also like my videos if you feel that it is helpful for you for coding as well as the CP. So thank you, and stay healthy, and also be healthy mentally. Thank you.